such type of chemical reaction are called the galvanic cell or voltaic cell. So what does that means? Because galvanic cell and voltaic cell is used to create electricity by using a chemical reaction. So we all know that nowadays the world is basically why it runs for? It runs for energy. So we know that Saudi Arab or the Middle East Asia basically they boast of power. What for? This is because they have a large stock of petroleum. So the country like India, China, we basically import petrol from them or diesel from them or crude petroleum from them, and we try to produce power, because otherwise this power or energy, as if nothing will run. Basically no electricity will be there, no car will be there, no van will be there, the transport system or many other electronic gadgets, everything will stop. So the country which has the basic materials to produce power, so that is basically the richest country nowadays. So the thing is that when in my chemistry book or during my study, if I understand or if I know that there are some specific type of chemical reactions which is oxidation and reduction reaction, and that can produce electricity, so why not to use that electricity for our benefit? So in this background, basically people have tried to use a different type of cell which is called the galvanic cell or voltaic cell. Let's look at how it looks like. So you can see that I have taken two different type of basically jars where two metals are there. One is zinc metal, another is the copper metal. So what I have done, that I have put an electric wire in between them, that I have told that otherwise the connection between them or collision between them, the chemical reaction cannot happen. So I have put an wire. Wire means we all know this is a metal wire. So you can see that as soon as I connect it, and if I put a light bulb, actually what it will do, the light bulb basically it switch on, it will give you light. So it means that chemical reaction is occurring between this zinc and copper. It means that electron is moving. So how the electron moves? The electron moves in this way, that from zinc 2 electron goes to this copper dipositive, and now after leaving this 2 electron, zinc has become the zinc 2 positive and copper dipositive has become copper, means 2 plus. After getting 2 electron, it converts to the copper metal. Now zinc, which was earlier metal, it has now converted to the zinc 2 plus. So how it happens? Because already we know that basically such type of cells where the electron exchange is spontaneous. So in that case, it means that between these two metal, someone is there who is a great boxer compared to the other one. It means the copper has a strong capacity to pull the electron. That copper has a strong capacity to pull the electron, and zinc has the weaker capacity to pull the electron. So while they are colliding with each other, means to continue a chemical reaction, so it means copper will win and it will snatch the 2 electron from the zinc, and it will in the long run it will produce electricity for us. So this is what the normal galvanic cell or the voltaic cell, how it creates the electricity using a simple chemical reaction. So now what is this oxidation? Because already I have told all of you that there is oxidation and reduction reaction. Oxidation means it is the loss of electron, and what is this reduction? Reduction means it is the gain of electron. When something is getting reduced, mean it is gaining electron, and something is getting oxidized, it means that it is losing electron. So when it is happening on its own in case of this zinc and copper that already we have seen. So what we will tell, it is a spontaneous process. Spontaneous process means you don't require any other forces from outside to pull this electron or this exchange of electron to happen, right? So how can I understood this thing that my zinc has the weaker capacity to pull the electron and copper has the higher capacity or stronger to pull the electron? Because all of we know there is a list in your class note also, there is a list that is basically called the standard reduction potential. The potential means a power. So who can have the better reduction, who has the highest power to reduce in a proper way, in a better way, a stronger way? So this is a list, this is already been there in your class note. So you can follow the list that fluorine after addition of 2 electron it is getting 2F minus, means fluoride, and chlorine after getting 2 electron it is getting chloride, and copper 2 positive after getting 2 electron it become the metal copper, and nickel 2 positive after getting 2 electron it is getting nickel, and zinc 2 positive after getting 2 electron it gets zinc, and same for the calcium and the lithium. Now you can follow this sign also, that it is plus 2.87, so it means that it is the highest in this list, that because plus sign is there and also 2.87, and among all these lists it means that fluorine has the stronger pull for the electron. And as soon as you are moving from this lower portion to the upper portion of this list, you will find that the more these elements basically they can have the more power to pull the electron compared to which one is just below to them or below or to its own position. So if I compare the my example that what I have already shown to you, that is the copper and zinc, what you will find that in case of copper, the reduction, that copper 2 plus is getting 2 electron, because already we know that the reduction means that gain of electron. So copper 2 plus 2 electron, it gives you 2 copper, means plus 0.34. and now you can see the zinc one, that zinc 2 plus 2 electron, it gives you zinc, so which is minus 0.76. now if you ask me, if I can ask you that the question that which one is higher, so automatically the answer is plus 0.34. so whatever already we have told you, or whatever I have told you, that the copper has the higher capacity to pull the electrons, so it means it is being proved by the list of the standard reduction potential. Now I am coming that the deeper sense of this galvanic cell that already I have introduced. A thing is that when you are reading a galvanic cell, so it means that you have taken zinc, one metal in this left hand side and one metal in the right hand side, and you have put a wire over it. So what you are doing, that you dip this metal in a solution, and here also you have dipped this metal in a solution, and what these metals are called, these are called electrode. So there is a specific name for this electrode. One is called anode. Anode means where oxidation happens, and another is called cathode, where reduction happens. So it means this zinc one, what it is doing, it is basically losing electron, and already what I have told that oxidation means loss of electron. So oxidation is happening at this electrode, and copper what it is doing, it is gaining the electron, that already I have told the reduction means the gain of electron. So it implies that the reduction is occurring in this electrode. So what should I call this electrode? This is called cathode, and this one will be the anode, because the definition of this anode and cathode like this, that where oxidation happens it is anode, and where reduction happens it is cathode. Now there is a simple way, that anox, red cat, means anode where oxidation happens, reduction happens, it is called cathode. So I hope you can easily remember this thing, that and you will not forget, or you will not jumble up in the examination, fumble in the examination. Basically anox, red cat, the reduction happens in cathode only, and anode, oxidation happens. Hope you are following my lectures. Now the second thing, what I have told, that electricity makes chemical reaction happen that would happen otherwise, because we know that there are several types of chemical reaction. Sometimes you require heat, sometimes you require stirring, sometimes you require pressure, or several properties are there which is basically necessary for doing a chemical reaction. So in this electrochemistry, so this is one type of chemical reaction. This chemical reaction, without providing electricity, this chemical reaction cannot happen. So I am taking a very simple example, that is that the dissociation of water into its own component, that is hydrogen and oxygen. So it is an unbalanced equation, because we know that I have not done any balancing, because if you do the balancing, then it will happen that 2H2O plus 2H2 plus O2. So because it is not our now it is not very much important in this case, so I have written an unbalanced equation. Now how it happens, let's see. So what we have done, that we already have told you that if reaction is not happening spontaneously, if you have to use some force, outside force, then what we do, we use the battery. So it means that we have two different electrodes, and two different electrodes had been connected with where, with a battery. This is a positive side or negative side, and this procedure is called the electrolysis. We know what this means. Lysis means that something you want to break, right? So electrolysis means you are using the electricity or the force of electricity to make this lysis thing happen. Means we are trying to break the bond between the hydrogen and oxygen to give the hydrogen and oxygen from the water. So we are trying to we are trying to lysis. So this lysis means, this electrolysis means you are using the electricity to breaking something. So it is called the electrolysis. And what this cell we can tell, earlier I have told that was which produced the electricity, that is called the galvanic cell, and it one is called the electrolytic cell. Electrolytic cell means a device for doing electrolysis, a device for doing electrolysis, right? Hope you can understand the difference between these two type of cells. One is to produce the electricity, one is to use the electricity to make the chemical reaction to happen, right? Hope you understood this thing. Now what the process basically happens, that already I have told you that electron is being pulled up, or electron is being exchanged between the two components, or forcefully exchanged, you can tell, to make this electrolysis process happen. That H2O, it is being dissociated into H2 plus O2. Now you see the oxidation number over hydrogen, it is +1, and oxidation number over oxygen, it is -2. So you see that after the reaction it is 0, it is also 0. It means that whenever the element is in its normal form or standardized form, so their oxidation number will be 0. So you see that +1 has been converted to 0. Means how it can +1 means it is a dearth of electron, or it requires electron, so it takes one electron. So when H plus takes one electron, then it gives you H. So it means a reduction is happening here, that hydrogen gains electron. And what this oxygen 2 minus is doing, oxygen 2 minus is basically losing 2 electron to get the oxygen. It basically losing 2 electron to get the oxygen. Basically it is the oxygen atom, so I am not going to these details. So basically, so I have to write the 2 oxygen and 4 E that give you the O2. So this oxygen is losing the electron, oxygen is losing the electron, and hydrogen is gaining electron. So this is a process that electron is being exchanged between oxygen and hydrogen, and by this process the bond between hydrogen and oxygen, because we know that the structure of water is like this, so these bonds are being broken. These bonds are being broken with the help of the electricity. Now this things is that what is happening here, that hydrogen is gaining electron and oxygen is losing electron. But if you follow the standard reduction potential table which has been given to you, you will find that oxygen does not want to lose electron, because oxygen has the stronger capacity to pull the electron with itself, and hydrogen also does not want to gain the electron, because hydrogen has a lesser capacity to pull the electron with itself. So if you compare it with the earlier galvanic cell, that zinc and copper, the war between zinc and copper, that who will win, then you can find that there basically copper have won over the zinc, because copper had the stronger power to pull out the electron from the zinc. But in this case, what is happening, it is completely different to their will. So when you are trying to make some person that he do not want to do that, so what you require? You require some outside force. So this battery basically is which is providing the electricity or electrical force, is doing my outside force. So it is trying to pull out the electron from the hydrogen and give it back to the oxygen, which is against their will actually. So how this happen, you can already understand that you are using electrical force from the outside to make this reaction happen, because this reaction is very important, because splitting of water gives you this hydrogen gas. And nowadays we all have heard about, there are several type of researches regarding the clean energy, because whenever you use the hydrogen or oxygen, such type of thing, so what you get in the long run, you get the water vapor, and this water vapor does not cause anything harm, or it is not a greenhouse gas. So instead of carbon dioxide, if I get the water vapor in my water, so the our climate will be the pollution free. So people are trying to make the hydrogen oriented fuel. So stripping out this hydrogen, because hydrogen is a very lightest element among most of the elements in the air. So what happens, that it remains at a very lesser amount, very minute amount in the air, and also it remains in the very upper layer of the air. So because it is very light in weight, so we know that something is light in the weight, it means it will float. So if we take that air is a chamber, so automatically the hydrogen will float over the chamber of gas, right? So getting this hydrogen from the air, it cost very much. So this is the one of the way that getting hydrogen from the water. So it is one type of research is going on. It's a very recent research is going on over this, to making the hydrogen cell, because if we can use the water very efficiently to produce the hydrogen, and this hydrogen, we know that it itself burns, that what the petroleum and diesels do, itself burns. So automatically the engine problem, that how to transport transport problem is solved, because we are getting energy from hydrogen. So this hydrogen is very much important in the modern world. So this reaction is also very much, so I have picked up this reaction, so this is that part significant. So let's come to the actual thing, that from oxygen to hydrogen, electron is moving, so which is basically against the will of oxygen, because oxygen is electronegative element, or its electron affinity is also very high. It means that it will try to pull electron, try to keep electron with itself. It does not want to lose the electron to anybody. If we are not, I'm not using fluorine, etc., right? But especially in case of hydrogen, which is lower capacity to pull the electron. I hope that all of you have understood this, the difference between the electrolytic cell and the voltaic cell. Now let go deeper way of this voltaic cell. So what this voltaic cell, I have told there that we have used these two different electrode, one is zinc and another is copper, and it has they both has been dipped in two different solution. One is zinc sulfate solution in zinc, and copper is in the copper sulfate solution. So what is happening here, that zinc sulfate solution means this is the zinc electrode and this is zinc sulfate, because we know that the zinc sulfate is basically give you Zn2 plus and SO4 2 minus. SO4 2 minus. The zinc sulfate dissociate in the way that Zn2 plus and SO4 2 minus. I have purposefully not omitted this SO4. I will come back to you that what is the use of this SO4 2 minus later. So in this solution, what we get? I got a zinc electrode where zinc is neutral when it is in the form of solid or in the form of metal, and while it is in the solution or aqueous solution, actually basically it is, so it is in the ionic form, that is Zn2 plus, because zinc requires electron here. And now another part of this voltaic cell, that is the copper sulfate solution I have used there, that I have already told that copper sulfate solution I have used. So this copper sulfate solution dissociate into copper 2 plus plus sulfate 2 minus negative ion. So here also same case, that in the electrode that I have dipped in this aqueous solution of copper sulfate, it contains the neutral copper, that means copper has no charge actually over it, but whenever it is in the solution, so copper has charges, which is copper 2 plus, right? Now the things is that whenever I put one wire over it, so what happens, that zinc basically give up 2 electrons, that already the reaction we have written, that zinc give up 2 electron through this wire. And what happens, after zinc giving up these 2 electrons, the zinc converted to zinc 2 positive. Zinc converted to zinc 2 positive. So zinc is basically this electrode is basically deteriorating basically. So more and more zinc coming to the aqueous solution in the form of zinc 2 plus. And what happened here is, because copper is taking to these 2 electron, because copper has the higher capacity to gain the electron, to pull the electron. So the copper sulfate which were present in the earlier solution, so it takes up 2 electron, so Cu2 plus 2 electron, that gives you the copper. So this copper is again going back to the electrode and it deposited over the electrode. So it means that this electrode is basically increasing its size by gaining more and more copper from the solution, which has been converted from copper 2 plus 2 after getting the 2 electron, and this electrode is basically depleting by the course of reaction as the reaction is progressing. So I am showing you this the condition after reaction has been progressed for sufficient time, that zinc has been just stripped like something, that maximum of the portion of the zinc has been gone to the solution, and this copper you see, imagine the size, that already this there is a lot of copper has been deposited over the original electrode, and you see the bumps over the electrode. So this is the condition. So there are two half reaction basically happens in this two different cells. First half reaction is the zinc solid, that gives up 2 electron, that zinc 2 positive plus 2 electron, and another half reaction is the copper 2 plus 2 electron, that gives you copper solid which has been deposited over this copper. So copper 2 plus is going to deposit over it by gaining the 2 electron. So this is half reaction, this is half reaction. So it means that 2 chambers are there, 2 chambers over there, and 2 half reaction are going there. So the problem will come in this case that over some time what will happen, that in this solution more and more zinc 2 positive will come to this solution, and in this solution, since most of the copper has been deposited over this electrode, So this solution will have containing the more and more SO4 2 minus. So one side there is a charge disbalance. It means that one side there is a deposition, of zinc 2 plus ion in the solution, compared to that how much SO4 2 minus should be there. In another side there is more and more deposition or accumulation of SO4 2 minus solution. So what will happen, that after some time this reaction will stop. So what is the way out? The way out is the salt bridge. The way out is the salt bridge. So what this salt bridge do basically? The salt bridge basically contains the KCl solution or NaCl solution. I have shown here the NaCl solution. Just a minute. KCl solution or NaCl solution. I have shown here NaCl solution. Here people put some cotton over here. What happens that this NaCl solution, so you find that Na plus Cl minus is there. Now in this solution, the left hand side, the cathode left hand side one, what happened that more and more zinc 2 positive is there, and in this side more and more copper sulfate 2 minus is there. So it means that it will try to pull up the opposite charge, means zinc 2 positive will try to take this chlorine negative towards this section, and this sulfate 2 minus, it will try to bring the sodium plus 1 to this section, right? So this happens is actually that more and more chloride come to this one, so basically to make this charge in a balanced way, and here also the more and more sodium plus come through this cotton in the over the solution to make this charge in a balanced way. Otherwise the reaction will stop, because there is a barrier will create, a biasness will be being created in these two cells, and after a few seconds or few minutes the reaction will stop. So if we use a salt bridge which contains the ions, easily ionizable ions like sodium chloride or potassium chloride, and we are basically using cotton, that the solution should not come all over out from this basically U tube, actually it's a U-shaped tube. Only ion should come which can come through the pores of this cotton actually. Sometime agar-agar jelly also being used in the salt bridge. So this is the utility of salt bridge, because it is being used to balance the charge between the two half cells. Otherwise the reaction will stop after some time, so we will not get electricity for long time, that at least up to the completion of the reaction. So now the next thing is that we have already come across about the notation of that how to write this type of chemical reaction, electrochemical reaction. I would like to tell that left hand side always you should write the oxidation portion, and right hand side you should write the reduction portion or the reaction which is being happened on the cathode. Now follow the reaction, that zinc solid 1. So since zinc is a solid and it is in the aqueous form, it is an ion, so I put a single slash, the zinc solid, where the oxidation is occurring. Zinc solid releasing 2 electron, so it is producing zinc 2 plus. Then I have put this double dagger, which basically denotes the salt bridge present, which is a salt bridge present in this to connect the two half cell to balance the charge. Then copper 2 plus is taking up that electron which has been given up by the zinc, and it makes the copper which is being deposited over this electrode. So this is the way that how we write the electrochemical reaction, that it is a full cell notation, that how to write. Left hand side should be the oxidation or anode portion, and right hand side should be the reduction or the cathode portion. Hope you have understand this much portion. So next day I will come with another portion of this electrochemistry. All the best, stay safe and keep healthy. Thank you very much. If you could not understood any of my portion that I have taught you, then kindly follow the note that has been circulated to you, or you can ring me, or you can give me the WhatsApp that your queries. I will try to solve it out, or you can call me also, no problem. Thank you very much.